discard. And file, open. Ooh, look, there it is. No, that's, I mean, I just saw something. There it is, perfect. Where were we? We were way down here. Effect. There we go, all right. So one of the questions about the rise of services is the one we answered, which is how come? Another question about the rise of services is so what? So maybe this rise of services just is what it is, and maybe it has no implications whatsoever. This is the work that I've been doing most recently with co-author Aaron Pasidi, who I met last year when I was on leave. And the question that we're asking in the paper, I didn't assign the paper. You can look at it if you want. It's on my website. I'd love to have you look at it, but it's not required to look at it. So the question we're asking is whether or not there's a macroeconomic effect. So those of you who had me for Econ 1 or 100B heard me talk about this because I have believed for many years that the rise of services is contributing to lengthening of economic cycles. That when you have an economy that is largely a service-dependent economy, that it makes it harder for recovery to take hold in that economy when we're coming out of a recession. So that's the question that Aaron and I look at in this paper is whether or not cycles are longer in service-dependent economies. The way that we do it is by using state-level data. So we've got state data for 50 states over 5 recessions, so it's a panel of U.S. data. And we're going to look at the cycle length, so the amount of months from the peak to previous peak employment levels, control for the depth of the downturn, and see whether or not the share of services in a state leading into that recession has an effect on how long the cycle is. The answer is yes. The answer is that my hunch that I shared with all of you over the years in Econ 1 and 100B is that the share of services matters was in fact right, or at least is borne out by the evidence, which is always a wonderful thing to know. Sometimes, it's fun to just pontificate and not know whether you're right or not, but it's always nice to back up your pontifications with empirical evidence. And it appears that the shift toward services in the United States over the last century is adding about a year to the current recovery. So that if we were producing the amount of services today that we had been producing 50 years ago, the recovery we would be back to baseline a whole year sooner than will be the case. So let me show you how we get there. We started from this graph from the calculated risk blog, which I've mentioned multiple times in multiple classes. And this graph by calculated risk looks at how many months does it take in each of the various recessions for the economy, the U.S. national economy, to get back to baseline, where baseline is measured by the amount of employment. And so if you trace any particular recession here, so here's the 1980, the 1980 recession. It's hard to pick out because there's so many different colors here, but they all start here at 0 because that's the start of the downturn. And then you go along and you follow a line down, and it keeps going down so long as employment is declining. And then you can see how many months does it take until we hit bottom. And then employment starts to recover, and then the question is how many months is it until we reach back to baseline. So the interesting thing that I noticed when I looked at this graph, and the guy that runs calculated risk adds a month to this graph every time the employment report comes out. Of course, the thing that everybody looks at and notices when they see that, of course, is here's 2007. So that the downturn that started in 2007, we're nowhere near back to baseline. We're still about 3 to 4% below the amount of employment that we had when the downturn began late in 2007. And here we are, 6 years out? It's a long time. But what I also noticed was that each of these lines seem to be getting further and further out. That the more recent downturns have been longer and longer and longer. And that was certainly consistent with my hunch, that having more services in the economy was making it harder for the recoveries to take hold and was stretching out business cycles. So that was where we started. And we looked at the national economy. That's only 11 data points because there's only 11 recessions, so it's not enough to really do any econometrics that are worth taking your time with. But what we saw there was a pattern that's revealed in the calculated risk website, which is that these cycles are longer, and that the cycles are longer not because the downturns are longer. So that the top picture is showing you the recession length on the left as measured by the NBER, that's the blue bar, and then the red bar is the whole employment cycle. So that's the peak to previous peak. So the recessions themselves are not substantially longer. It's the amount of time to go from peak to previous peak that's longer. In the bottom graph, what we did was we take basically the red bar and divide it by the blue bar. So take the ratio of the overall employment cycle, divide that by the NDER dated length of the recession, and you can see this increase over the last 30 years in the length the cycle is taking relative to the downturn. So what do? We take and look at how the cycle length is dependent upon the share of services. The cycle length is measured again as the number of months from peak to previous peak employment. We're looking at services share, so this is similar to the data that we've seen. So looking at output by industry, so the service-producing industries and what share of output by state is services, and measuring that as the 3-year average going into the recession. So certainly there's a possibility that as you go into a recession, an economy produces fewer goods going into the recession, and that would skew the share of services. So skip that. Measure the share of services for the 3 years prior to the recession starting, so that it's not skewed by what happens as you go into the recession itself. And then for the depth of the downturn, we measure the depth of the downturn as the percentage change in employment from the peak to the trough. This is done once again for a panel of states, so we've got 250 data points here. And then we're going to do at the end a counterfactual exercise to ask how much longer is the recovery from the 2007-2009 downturn due to the rise of services over the last half century. The way that we do that is we predict how long the cycle length would be for the coming out of 2007-2009 using the actual share of services for 2007. We predict it again using the share of services from 1957, and then we take the difference, and that difference shows you the effect of the rise of services over the last half century. There's a lot of wonderful variation by state. This is showing you the variation in cycle length in 1969 and 2001 for the 50 states. 2 things to notice. One is that for any given year, so the blue bars are 1969, the red bars are 2001. For any given year, different states have different experiences. So it's not that all states are experiencing the same length of downturn. It varies a lot from state to state. The other thing to notice is that the rank ordering from lowest to highest mixes up. So this graph is in order by the blue bars, which is the length of the cycle in 1969. If I had put the states in order by the red bars, they'd be in a different order. So there's a lot of variation within year, and there's a lot of mixing up of the order between years. That kind of mixing up, that kind of variation is really good for econometric purposes. The share of services by state, again, not the same in every state. So in 1960, the average 67-69 is lowest here in Alaska and highest in Nevada, a difference between 38 and about 62%. So a lot of difference within year, and again, a lot of mixing up between years. So that the rank order is here based on 67 to 69. Where are we? We're way down here at the end. California's way down here. If I re-rank ordered them from using the 2007 shares, it would be in a different rank order. And same with the depth. So the depth, again, a lot of difference within recession, a lot of mixing up of the rankings between recessions. The econometrics that we did is pretty straightforward. It's just estimating that cycle length, controlling for the depth of the downturn, and giving a role to services as a share of GDP by state. The first 5 columns there, and I think I put this in the handout. The first 5 columns there are doing standard OLS that you would learn in 140 with fixed effects. So we're saying there's probably some, no doubt, there are unmeasurable things that are common to each state that we haven't captured, and so we're going to do what they call fixed effects by state. It's essentially the same thing as dummying out all of the states. So you get essentially the same results. This is also how they did the work in the Rothman and Ramaswamy. So they dummied out each of the countries. So it's a very similar approach. When you do that, you get a statistically significant, statistically significant role for the share of services in 3 of these 5 columns. And the key is kicking out Nevada and Hawaii. So in those first estimates, when we kick out Nevada and Hawaii, we get the result that I expected, which is that the higher the services share, the longer the downturn. Why Hawaii and Nevada? Those are the 2 states that can export a lot of their services. It's pretty difficult to export a haircut. It's pretty difficult to export a teeth cleaning. But if you're in the business of providing gambling as your primary service activity, that's exported every time somebody from Arizona comes into Las Vegas and goes to the casino. That's an export from Nevada to Arizona. So to the extent that Nevadans are not the people who are gambling in Las Vegas and Reno, then most of the services being produced in Nevada are being exported out of the state. Same is true for Hawaii. Hawaii, the services they produce, very heavily service-dependent state, services they're producing are luau's and beach condos. People who live in Honolulu, they are not the ones who are going to the luau's and the beach condos. Those are all people from California and Washington and Japan and other places. It doesn't matter whether these things are exported out of the state and into the country or out of the country. The point is that these are exports of services that are easily exported, so we do them. Yeah, what about the financial services that are headquartered in New York? Turns out that the financial services industry, yes, is headquartered in New York, but the financial services is not a huge share of it's not that the bulk of services produced in New York are exported out of the country. So it makes it very different than the role of tourism in Nevada and Hawaii. So whether we included or excluded New York didn't make any difference. That particular question is hard for me to answer. So I don't know. Bank of America, I think, like I have Bank of America. Bank of America is headquartered in North Carolina, but the branch is in California. So I think that's still all within the state of California. The exporting of financial services is when the investment bankers in New York are doing a deal for somebody in Rhode Island. Okay. The last 2 columns use what's called a Tobit regression. One of the things that you might have noticed on those data is there are a bunch of states that in every recession don't go into recession, which means we've got a whole bunch of states for whom the number of months equals 0. Because they don't experience any downturn, and so their previous peak is 0 months because they never leave their previous peak. Using an OLS regression, so using a standard regression like we did in the first 5 columns and like you learned in 140, doesn't allow you to gather the information that is captured in the fact that your data set has a whole bunch of zeros in it. They call that having a truncated data set. I don't want to do a whole lot of econometric teaching here, but when you have a truncated data set, you want to allow for your fit. You want to allow for your relationship to really gather a lot of information from the fact that some of these values are cut off, thereby in this case equal to 0, and the others are allowed to vary. When you do that, you use what's called a Tobit. With the Tobit, it doesn't matter whether we include or exclude Nevada and Hawaii. It's a much better econometric method to use. Eventually in this paper, I think just the last 2 columns are the ones that we'll report. It doesn't matter whether you include or exclude Nevada and Hawaii. The services share has a big role to play in the length of the downturn. And the counterfactual effect is to lengthen the current downturn by between 11 and 15 months, so let's call it a year. You can see it in terms of I already told you my story. You can see it in terms of the pictures here. So I added the green bar. The green bar shows you how long the recovery would have been if services had stayed at their 1957 level. So if the share of services had not increased since 1957, each of these recent downturns would have been much shorter, and the current downturn would be up to a year shorter. Doesn't mean the current downturn would go away. It's still going to take us a long time because we had a very, very deep recession, but it would be shorter if we were producing more goods. Okay, how am I doing? Oh, good. Part of many of these stories has been productivity. So part of Rothman and Ramaswamy was productivity differences, and certainly part of our whole story in U.S. economic history has been looking at productivity. That A in our production function has been pretty important all the way along. So we're going to turn right now, and then again on Tuesdays, I'm not going to get all the way through this, but I can show you the pictures, to looking at what's happened to productivity growth rates over the last half century or so. Now, extensive growth, just to throw back to the very first day of class, when we talk about extensive growth of an economy, we're talking about increases in the amount of capital, that's actually or, let me add it here, or an increase in labor, or when we did the 19th century, we had or an increase in land. At this point in the 21st century, we don't care about land anymore, so we don't need land in our production function for the 21st century. When we talk about intensive growth, that's increases in productivity. So when we had our production function, y equals a times some function of capital and labor, the intensive growth is increases in a. When we start trying to measure productivity, so we want to go out and gather some data so we can look at these patterns, there are 2 ways to measure productivity. One is average labor productivity, or what's in the Styro article called ALP for average labor productivity. And average labor productivity is simply the amount of output per worker. That is the same as Y over L. So average labor productivity is the same Y over L that we use as the left-hand side variable when we talk about output per worker as a function of the capital labor ratio and the land to labor ratio. So it's saying that one measure, and that's the easiest thing to measure, is this Y over L is is the average labor productivity. The other approach to measuring productivity is multi-factor or total factor productivity. That's the A. So that when we have output per worker is A times some function of the capital labor ratio, the total factor productivity or multi-factor productivity, that's the A in that equation. In order to measure output per worker, the average labor productivity, that's pretty straightforward. To measure average labor productivity, we need a measure of output, and we need a measure of the amount of workers. And those data are gathered all the time. The output measures are gathered all the time to build GDP. The labor measures are gathered on a monthly basis, as we know, to create all those BLS reports. To measure multi-factor productivity, the A in this production function, requires having measures of capital, having measures of labor, having measures of output, and then specifying precisely what's the mathematical form of that function F. And that involves some assumptions about what's the nature of the aggregate production function for the economy. So estimates of total factor productivity are always estimates. They're always based on assumptions about how the capital and labor combine to produce output. Is it a Cobb-Douglas production function? Is it a CES production function? What kind of production function is it? What's the right assumption to use? So those things are always subject to debate and are much harder to measure. So everything I'm going to show you is average labor productivity. Here we go. If we look at productivity growth rate, so now what we're looking at is not the level of output per worker, but the percentage change in output per worker from year to year. If we look at productivity growth rates, here this is 1960 to 2012. The darker line there is the non-farm business, so it's everything but farms. And the purplish line is manufacturing, so I just pulled out manufacturing. First thing that there's a whole bunch of things we can see. One is, I marked off the zero line here to call to your attention that almost always productivity is growing. That productivity, the amount of output per worker, declines only in those occasions when the productivity growth rate is below zero, and the times when the productivity growth rate is below zero tend to be, are times of economic recession. Productivity growth rate will fall below zero in economic recession if firms don't fire their workers. If they cut back on how much they're producing, but they don't lay off their workers, the output goes down, the labor doesn't go down, productivity growth rates can, in the extreme, decline. Happens rarely, isn't very common, so most of the story is about productivity growth. Most of the time, the percentage change in output per worker is greater than zero. It's above that line. The second thing that I would notice from that graph is it jiggity a lot, right? There's nothing smooth about that graph whatsoever. It's going up and down, up and down, up and down. So productivity growth fluctuates a lot from year to year, quarter to quarter. The third thing to notice is that manufacturing productivity and overall non-farm business productivity, those things don't move together. Those two lines, you can see a difference between those lines lots of times. Sometimes they're on top of each other, but oftentimes they're not. So the first thing to do is to smooth, first thing to do is to smooth it out. So pretty common method to smooth it out here, I took what's called a 5-year moving average. And so the value that's reported for, say, 1982 is actually equal to the average for 1980 to 1984. The value that's reported for 1983 is the average for 1981 to 1985. So it's a 5-year moving average, and what it does is it gets rid of all the jiggity-jaggedy, so it's much easier to see what's actually going on over time. And when you do that, you see first, it's much easier to see that manufacturing productivity growth is typically much higher than the productivity growth of the economy as a whole. That was the premise of Rothman and Ramaswamy, that manufacturing productivity growth is going to be greater than productivity growth for all else. So here we've got productivity growth for manufacturing and productivity growth for everything. So you kind of have to make in your head another line there that is the sort of the green minus the red. Actually, I'll do that for you later on. What else do we want to see? The other thing that you might be able to pick out from that is that the averages are different over time. So we're going to show you that here. This is showing you the actual labor productivity. So this is not the percentage change. This is the actual levels of output per worker. And what happened is the rate at which productivity was growing changes from time period to time period. So from 1960 to 1973, period 1 here, the trend rate of growth was almost 3%, 2.8%. That's considered the golden years of productivity growth. That was fabulous. Because when output per worker is growing about 3% per year, then pretty much per capita incomes are going to be growing about 3% per year in real terms, which would be pretty fabulous. Then we entered the period of the productivity growth slowdown. So 1974 to 1994, the trend rate of growth was just 1.5%, about half as much. That cutting in half the trend rate of growth, that impacts how quickly people's living standards rise. Then we got the resurgence. Oh my gosh. Then we get period 3, which is 1995 to 2004, and economists were giddy. I mean, in the same way there's all this buzz this week about the Rothman and Ramaswamy, people were giddy about productivity growth going into around 2000, 2001 because we had this resurgence in productivity growth with a trend rate of growth of 3.3%. But if you extend it all the way to today, that's number 4, the trend rate of growth from 1995 till today is only 2.4%. So we had a resurgence, but that resurgence has sort of gone away a little bit in the last few years. Where I'll start on Tuesday is the outcomes. Y'all have a great weekend. Enjoy the weather. Go for a bike ride or something. I'm going for a bike ride. Write the paper.